Okay, welcome back. We're talking about the vector data model this week. Last time I kind of gave you an overview of what we're going to cover in this module and then reviewed the basics of the vector model: points, lines, polygons, topology. This time I need to talk a little bit about data structures and how we actually represent reality when we have to jam it inside of a computer. So we've got this three-dimensional Earth, and we're going to model some aspect of the three-dimensional Earth using the vector GIS data model. We need to get what it is we need from the Earth and put it into our computer, and we're going to do that using a code that the computer can store and manipulate, and that code's going to be what's called a binary code. A lot of you folks probably already know all about binary code, but since this course doesn't have any prerequisites, maybe some of you don't, so I'll go over the basics of how the computer stores information. So this is a binary code. Binary means two options. In this case, we're going to represent those as zeros and ones. Each piece of that binary code is called a bit, and that's short for binary digit. So any single 0 or 1 is a bit, a binary digit. If we put 8 of those together in a piece, we're going to call that a byte. So a byte is 8 bits. If we take 2 to the 10th, 2 to the power of 10 bytes, that's what's called a kilobyte. 2 to the 20 is a megabyte. 2 to the 30 is a gigabyte. And you might imagine that maybe 2 to the 40 is a terabyte. Sure enough. So that's what all those words mean. Those are numbers of bytes, each byte consisting of 8 bits. In the base 10 numeral system, you're all used to that. 1011 in base 10 is 1011. Straightforward, everyone remembers that. It's 1 times 10 to the 0, base 10, notice that's 10 to the 0, plus 1 times 10 to the 1, plus 0 times 10 squared, plus 1 times 10 to the third. You add up all of those and you get 1011. So you'll notice that this placeholder is the placeholder for the 0th power. This for the first, the second, and the third. The 0 or the 1 binary digit is multiplied by the base to that power. That's how you do base 10. Well, base 2 is going to be the same as base 10, except instead of using 10s, it's going to use 2s. So now we have this 1011 in binary, base 2. How does that work? 1 times 2 to the 0, plus 1 times 2 to the 1, plus 0 times 2 squared, plus 1 times 2 cubed. Add up all three, and it's really the number 11. So if we wanted to represent the number 11 in a base 2 or a binary system, we would do it with 1011. That, at this base, is how the computer is storing numbers. What about text? You can't put a number to a text. 00000 equals 0. 111111 equals 255. Those are the decimal representations in base 10 of this binary representation. So this is 0 times 2, 0, 0, 0, 0, so it's equal to 0. This is 1 times 2 to the 0, 2 to the 1, 2 squared, 2 cubed, 2 to the 4th, 5th, 6th, 7th. So that's 255. But if we use what's called a character set, we can assign numeric values to textual characters, and then instead of trying to store the character, we can store the numeric value, and if the computer knows it's text and it knows there's a value, it can look it up in the character set and it'll know what the character is. So there are different kinds of character sets. They've kind of evolved over the ages. ASCII being the first character set that was used, it only went from 0 to 255. ANSI went to a higher number of characters, and Unicode has gone to an even higher number of characters. The issue here is if you only have 256 different numbers you can represent with 1 byte of information, then your character set can only contain 256 characters. So in order to move to these character sets that have more characters, you need more space. So you need more than 1 byte to represent text in these newer character sets. Okay, that's how things get stored. Numbers as numbers in binary, textual information as numbers that represent some character set that's accepted as that type of text. Okay, so what kind of terminology are we going to use for the vector model? What I have here is I have polygons, 3 different polygons, Washington, Oregon, and Idaho. These polygons, if they apply topology, will have shared borders, no overlaps, no slivers in there. And there's information about all the vertices and nodes on each one of these polygons that's got to be stored in the computer somewhere. And that gets stored in a table, and that table is going to have a column in it called the shape column. So this is where the information about Washington is stored. So the x's and y's of all the points in the Washington polygon are stored right in here. Okay, each row of this table is going to represent a different polygon feature. So you can see we have a Washington row, an Idaho row, and an Oregon row, 1 row for each polygon. So we're going to call each one of these rows a feature. So that's a single point, a single line, or a single polygon. Okay? A feature class is a collection of features that have the same type, so they're all polygons, all lines, or all points, and they have to have the same projection in order to fit so that the x's and y's of each one of these are based upon the same projection information. Okay? So this is what's called the geometry of the feature class. This object ID, sometimes the feature ID, FID columns, those are used to uniquely identify each row in your table, and we can use these numbers to link the geometry of the polygons to information about those polygons. And so I'll be talking about that in a later video, but that's basically how it's going to work. So this is the where information. This is what information. What do we know about Washington? What do we know about Idaho and Oregon? The whats. These numbers are going to allow you to link wheres to whats. That's what a feature class is. Okay, here we have another feature class or another map that actually has points, lines, and polygons. So you can see that there are some points in here, fire hydrants, there are water lines, and there are parcels. So you remember everything that there is to know about points, lines, and polygons. Topology, things like the water lines must be connected, the parcels must share adjacent boundaries, when you have something that uses different feature classes, different types of features or different themes of features, but it wants to group them together so that you can work with them all as a unit, you use what's called a data set. So that's a data set. In this case, we have a data set that includes fire hydrants, parcels, water lines, and water valves. If we want to work with this data set as one unit in terms of finding out where the fire hydrants are based upon the water lines or things like that, we're going to need to use what's called a data set. So this data set is made up of feature classes, points, lines, or polygons. A feature data set is a collection of feature classes of the same projection. So remember, feature classes are a collection of features. Feature data set is a collection of feature classes, so it's a higher level collection. There's this thing called the georelational vector model, and what that does is it allows you to connect the where information with the what information in what's called the relational database function. And so what you're able to do is link the wheres to the whats using the georelational vector model. There's also an object-based vector model, which is a newer model that's used nowadays, and that allows you to not only store where and what information like you can in these two, but also information about things like topology and behaviors and other things. So you can think of an object as like a thing, a person, let's say, and a person might have a height, a weight, hair color. Those are all properties. Those are what's about the person. But the person might also be able to play, or might sing well, or things like that. And those are things that are characteristics of that object, but they're more like verbs. They're behavioral aspects of the object. So that's what the object-based model is. It's a little bit more modern. How do we store this stuff? In the georelational model, we have the spatial, the where, and the what data stored in separate files, so we link those together. The way we link them together is through that what's called a key field, which in this case might be the object ID or the FID field in that table that I was showing you a little bit earlier. So this is the oldest georelational vector model. It's called the coverage. And when you look at a coverage, it looks like this in ArcGIS, and it contains these different pieces in here. So you can see these are points, these are polygons, these are lines, these are points. So the coverage model stores these things in these separate feature classes, the equivalent of feature classes. It actually stores them physically, if I look in Windows Explorer, in one of two different folders, an info folder or the name of the coverage folder. So if you look inside the info folder, you see a whole boatload of these files. You look in this folder, you see a whole boatload of other files. So the coverage storage model was really complicated, and it was the first one that ArcGIS used back in the early days of Esri. And so it was really hard for people to deal with all these different files, not knowing what was in any of those files. Okay, people complained about that, and so Esri came up with kind of a streamlined way of storing data along with the definition of how the data are stored, and that's called shapefile. When you look in ArcGIS, you'll see that shapefile looks like a single file inside of a folder like this. It has a SHP extension. When you look in Windows Explorer, you'll see that it's really not one file, but it's 6, 7 files, depending upon what all are included in this shapefile. So this is better than the coverage model, but it's still a little bit complicated. So you can see that the where is stored in this file. The what is stored in this file. This is where the georeferencing or the projection information is stored. This is where the metadata is stored. This is a lock so that if somebody's looking at this file or editing this file, no one else can use it, so that you don't get two people trying to use the same file and change it at the same time. And this is an index which makes it easier to search for things in the file. So a shapefile can contain many of these individual files, or it can contain just a few of those, depending upon what information is associated with that file. So the moral of that story is, when you're messing with these shapefiles, it's best to use ArcCatalog to do it and not use Windows Explorer, because if you forget some of these files, you're not going to be getting the information you need when you move them or copy them or do things like that. Alright. Shapefiles were okay. Still, you had 6 files for each thing. People wanted really to be able to just give one file to someone and have them use that file and not have to deal with 6 files or anything like that. And back in the days of Microsoft Access, Esri came up with what's called a personal geodatabase. Databases look like this cylinder inside of ArcCatalog. And so, in this case, this database has a data set which has feature classes. If you look inside the personal geodatabase by opening it up in Microsoft Access, you see that there's a table in here that has information about the where, and it has information about the what. So there's a table in that database that has this information. You shouldn't try to go into Access and edit that. You should edit it through ArcGIS. Then there are these other tables that are called system tables. That's about how the database relates to itself. And there's the topology tables in case you have topology, so you can enforce topological rules. Remember topology from the last lecture: connectedness, adjacency, and enclosure. That's an MDB, personal geodatabase. Okay, turns out that people started storing bigger and bigger data sets, and MDB could only hold 2 GB of data. So now Esri has come up with what's called the file geodatabase. It's also a database. You can see the cylinder here. And it shows up as one folder with a GDB extension when you look in Windows Explorer. When you open that folder up, you're kind of back to where you were with the coverage, where you've got a whole boatload of files and tables that you don't really know what they mean. So you don't know what's going on inside of this file geodatabase, but ArcGIS takes care of that for you. That was a quick fly of data structures. Remember, the keys are feature classes, feature data sets. In these days, geodatabases are what you're going to use mostly, and shapefiles. Older data may be coverages, and you have to understand what coverages are in order to use those too. So this terminology, I'll be floating it out there for the rest of the course. Remember the terminology, cement it in your head, and you won't get stopped by trying to figure out what it is I'm talking about. So next time, I'm going to start talking about query and selection. That's how you can ask questions about your data that are going to help you use your data to transform it into information that's going to be able to tell a useful story. And that'll be next time.